Hello everyone, Elliot Severn here with the Discovery Museum's Henry B. DuPont III Planetarium, and today we're going to have a tour of some of the objects that you can find throughout the Milky Way galaxy. So we're starting here at the planet Earth, and we're going to back away to see our solar system. And as we back away, we can see the orbit of the moon passing by. And we're going to start to move much faster now and see the orbits of the planets and the various asteroids that orbit the sun. And asteroids all come in different groups. You can see the red ones are near-Earth asteroids, and there are main belt asteroids in between the orbits of Mars and Jupiter, and there are some Trojan asteroids in those blue areas, and those all clump together due to the gravity of Jupiter. And we're going to back away now and take a look at the flight path of Voyager 1. After launching in 1977, the Voyager 1 spacecraft explored Jupiter and Saturn and their moons, and is now the furthest spacecraft still in contact with Earth. It is now about 20 light hours away from the Sun, and is exiting our solar system. Each of the two Voyager spacecraft carried a record on board, a gold-plated record, in case any alien civilization ever discovers them after they fly out into interstellar space. Each record was etched with instructions on how to make a record player, information about our solar system and where to find it, and some information about DNA and human form. It included an audio recording called The Sounds of Earth, and that included greetings in many languages from around the world, and sounds of nature and music of many genres. As we exit the solar system now, we reach the outer reaches of the solar system, which is surrounded in an area known as the Oort cloud. It's a zone of icy debris. It extends almost halfway to the nearest star system, and it's where most comets come from. And as we exit the Oort cloud, we are going to fly further into our Milky Way galaxy, and we're going to see some objects around other star systems. And the first place we're going to go is the star system of 61 Virginis. And here we are at the 61 Virginis star system, and as you can see, it is a solar system of its own. It has planets around it. For a long time, astronomers proposed that stars other than the Sun might have planets orbiting them. It wasn't until 1992 that the first confirmed observation of an exoplanet was made. Ever since then, over 4,000 exoplanets have been discovered orbiting other stars within the Milky Way galaxy. And we're going to fly in closer now to the exoplanet 61 Virginis b. And here we are at this exoplanet. Now, exoplanets usually can't be observed directly. Astronomers often discover exoplanets by observing them transiting their star, which causes the star to get dimmer as seen from Earth, or by detecting slight wobbles of their host star from their gravitational pull. Now, exoplanets are too far away to observe in any detail, and so what we are seeing now is an artist's impression of what they imagine this exoplanet could look like. It is a rocky planet close to its star, and we know that it's very hot. As exoplanets pass in front of their host stars, it gives us an opportunity to analyze what gases might be present in their atmospheres. If we detect oxygen in the atmosphere of an exoplanet, it could point to evidence of alien life on a planet around another star. Up next is the Algol star system, also known as Beta Persei, or the Devil's Star. Algol is a variable star, which means that from Earth, it varies in brightness over time. Now, it was thought to be one variable star. It turns out, however, there is an explanation for this. It's actually a multiple star system. Out in our galaxy, some stars orbit other stars just like planets do, and that is the case with Algol. Algol consists of a tight binary pair orbiting a common center of mass. It has one hot blue star and one cooler yellow star. A third star orbits further away. And now we're heading off to the open cluster of M45, also known as the Pleiades cluster. An open cluster is a tight grouping of stars held together by gravity. And an open cluster could have anywhere between a few hundred to a few thousand stars in one tightly grouped area. As observed from Earth, here's what the Pleiades look like. There's over 4,000 stars in one tightly packed area. And here's what the Pleiades look like as we fly around them, and we can see the three-dimensional positions of its stars. Now we're going to head to another type of object in the Milky Way. We're going to head to a planetary nebula. We're going to head to M57, the Ring Nebula. And here we are at the Ring Nebula. It's a planetary nebula which is the result of a star at the end of its life cycle. It was recently a red giant star, and as it ran out of hydrogen fuel, it started to shed its outer layers and became a white dwarf. All of those extra gases expanded out into space, creating this bubble of gas that you see. A larger star will either go nova or supernova, but a medium or small size star will turn into a planetary nebula, as you see here. And we're actually going to go a little closer now, and we're going to fly through the Ring Nebula. Alright, there's one more type of object that we're going to show you on our Milky Way tour. We're going to take a look at a globular cluster. A globular cluster is a very tight grouping of stars. And they're very old stars. They're some of the oldest stars in the universe. And they're so tightly packed, it almost forms a globe shape, which is why we call it a globular cluster or a globular cluster, some say. An interesting thing about globular clusters is not only their age, but also where they're located in the Milky Way. The majority of stars in our galaxy lie within its disk. However, globular clusters lie outside the galactic plane. And you can see them here extending far above and below the plane of the Milky Way galaxy. And here we can see the whole Milky Way with its spiral arms and its nucleus in the center, surrounded by globular clusters. And that concludes our tour of the Milky Way today. Now we're going to set course for the planet Earth. And here we are back at home, hovering over the planet Earth. I hope you enjoyed our Milky Way tour today. Have a great week and clear skies.